Welcome to another episode of the Agronomy Highlights podcast. I'm your host, Ryan Spelman, and I am joined here with another agronomy extension educator, Justin Brackenridge. Justin, how are you doing today?
Good, Ryan. How are things going with you?
Things are going well. We have a really exciting topic here today, and I think one that a lot of our viewers will enjoy, and it's going to be new and emerging tech. So this is going to be a little bit different. We're trying some different things here, and it's going to be actually a two-parter. So we're going to divide this into two episodes, and we're going to bring on a bunch of folks to talk to us about new and emerging technology. Justin, why don't you talk a little bit about the guests we're going to have on today?
Yeah, sure. So we kind of paired today's with Dr. Paul Esker, who's an epidemiologist and a pathologist, and for the folks that are like me, that means he works with diseases and what causes them and how you stop them, right? And we've paired him with John Wallace, Dr. John Wallace, who is our extension weed specialist. And the reason we did this is their technologies kind of align a little bit. Paul is working with drones and applications like that, where Dr. Wallace is working with the see and spray technology and these types of things that turn on and off to reduce the amount of herbicides being used. And there's some common threads between the two of them, but some differences. And so we're really looking forward to understanding what kind of makes their lab group work and where the money is coming from and what's driving innovation in ag technology in their arenas today.
Yeah, Justin, I think that was a perfect introduction. We have a lot of exciting guests here today, and as you mentioned, Paul will be our first one. So, Paul, how are you doing today? Why don't you tell us a little bit about yourself?
No problem. Thanks, Ryan. Thanks, Justin. It's great to be here on the podcast. So yeah, just a little bit more maybe on my background. So I'm a professor at Penn State in the Department of Plant Pathology and Environmental Microbiology. We're primarily research, but we have extension and also teaching responsibilities. So the ag technology follows us across all three sectors, and what we do, much of what we do on the ag tech side, it's variable. Some of it's exploratory, I guess, at this moment. Others are driven more by a background in statistical or mathematical modeling that drives some of these other questions. But mainly overall, we're trying to understand how does some of this technology, drones, the models fit into an agricultural landscape such as the one we have here in Pennsylvania.
Yeah, so I guess that's a good part to start. And I should say, Paul is also my old advisor, so if I give him a hard time, that's a lie. So where do you see right now, how does drone technology fit in to agriculture?
So it's been an interesting change. I moved to Pennsylvania in 2017, and during early 2018, 2019, I would say there was a lot of interest in drones, especially for applying fungicides at that time. The problem I saw with some of the startups coming in, mainly what it was is a simple issue of not having a strong business plan. I don't want to criticize anybody, but you had to understand what kind of market you were dealing with. The technology and some of the technology for using drones in these settings still was something being worked on. And even today, fast forward how many years, 6, 7 years, we're still wrestling with a lot of questions in that respect. So in a parallel universe working in things like hemp, we saw that sort of same structure, a lot of interest in going in, maybe not the back end marketing plan. Fast forward now in the last year or two, and as we've seen things on our side, and for example, with tar spotted corn, lots of questions about timing a disease onset relative to the overall risk. We have seen not only with that, but I think with other technologies from utilizing drones or using other sensor technology, maybe more broadly, that we've seen an interest again, and there's a lot of new companies. Big difference is with some of these questions that are coming up, I think there is a market. Nonetheless, we've also seen the downside of where you're kind of running in parallel between research needs and actual application needs, where we've seen some examples where spray coverage, other things haven't been quite as effective as we had hoped. For us, we do the research on strips for certain targets, sclerotinia or the white mold pathogen being one. In other ways, we are building other projects into there to use other sensors, images, or otherwise to improve some of our scouting efforts. So these combination of things plus the farmer end, none of this works if the farmers don't buy into it. And I think we're seeing a shift in mindset. We're seeing some things that farmers can do there that allow them to purchase their own drone. Actually, we hear more and more of it in a year such as this, where they say, man, I would have had so much more control of my timing and things like that. So I'm kind of hitting on a lot of different areas, but all of these are kind of meshing together in how we're having to explore in real time, not just the spray technology. Is the boom width or is the width of the spray pattern sufficient for what it claims to be? Is it effective? Is it cost effective? But at the same time, how do you apply this, or how do you apply the technology across these different scales? And how do you, as a farmer, explore that technology on your own farm?
You brought up a lot of the current practices and comparing those to the drone technology. And we won't tell John Wallace or John Tooker this, but when we think about like insecticides or herbicides compared to fungicides, like fungicides by nature are kind of tricky to get where they need to be in the proper timing and all of the things, right? Because it's usually wet when we need them anyway, and then we can't get in there compared to some of the others. So how is that kind of, I don't know. I don't want to oversimplify the others, but fungicides have their own challenges just to get them out there accurately at any point, right?
Yeah, so across the crops, I mean, so we could start with small grains really quickly. I was at a meeting not quite a year ago, and this was a meeting with industry, academia, federal employees, among others, consultants. And somebody just brought up a simple question of who's dabbling with drones, and the hands kind of sheepishly went up, almost like when we talk to farmers to say who does this, and nobody wants to quite raise their hand. Everybody wasn't sure if this was a loaded question. It
Who's
was
got this
loaded.
problem? Well, maybe you don't. Whose neighbor has that problem, right? That kind of
Yeah,
a thing.
yeah, not me and my neighbor always, but the thing about it is it was a question brought up by somebody from industry, and I think we're all wrestling with the same thing. And just that question led to almost an hour's worth of conversation. And probably, if I remember right, I made a slide for the winter meetings last year, about 8 to 10 questions we would have with it. And from a disease perspective, if we start with small grains, our primary focus in Pennsylvania here in the east would be something along the lines of fusarium head scab or blight. And so there we know, it's one thing if we're looking at the foliar disease complex, it's another when we're trying to protect the head. We need to get that product where the flowers are. We know how to do it when we're running across with a spray boom on a tractor mount, or if we're running it in plot, we can adjust to that. But trying to mimic that with the drone when you have a lot of turbulent energy, how well are we depositing the product where it needs to be? And how do we measure that? And actually, this has become the most common question across all of them. How do you measure efficacy using spray cards or other things? Because they don't necessarily mimic the plant organ or what we're trying to protect. And so long conversations about that. If I switch to corn and I'm thinking of what I need to protect in corn, I'm looking at my ear leaf area. So the timing of most sprays around tasseling into R1 brown silk, those ranges, you've got to drive that product down. We've taken video from our backpack. We have these telescoping booms that allow us to mimic a ground rig. I can see almost like a rain coming down into the canopy, getting down to where I need it to go as we go through that. With the drone, we have a lot of energy. You've probably seen a lot of videos where corn stalks are moving all over the place. Same sort of question. Are we driving it down to where we need to? And how do you mimic protecting the ear leaf? Again, how do you measure that? It's not so straightforward. On soybean, it's another issue because there our primary emphasis is probably going to be on white mold, and so we're talking about protecting flowers. Same sort of thing we can see in our videos. Joey Akins took one for us from a trial last year, a former educator with our team. You just could see that canopy move about the whole time, and the real question was, are the droplets getting to where they need to protect what it needs to, and how much needs to get there? I mean, does the spray card telling us 3, 4, 5, 6, 7% coverage? Does it matter if it's actually getting to what it needs? And so for us, where is that line between disease control or disease management and protection versus adding water at a critical time of these growth stage? We can debate back and forth those sort of things, and that's what makes it a tough issue, because I can't always say what's going to work. I can see the worst case scenarios where the spray coverage is inadequate and we see these dark strips across field. But we're also learning through, I was talking to a colleague at the University of Wisconsin in agricultural and biosystems engineering there, who was talking about how when they measure kind of spray patterns in 3 dimensions using a kind of sort of a way to measure the wind and everything, you can actually see, they can see how at the tails of that spray boom width, if we use that as our frame of reference, what a spray boom width would look like, they can see that those droplets aren't being forced down in the same way as they are in the center part of the in the center part of the drone. And that'll have great impact, because now you have to think about overlap or other things as you run across the field, which becomes a less efficient sort of system. Probably the other thing with any of these that we had a conversation on is it may work in some situations, but field size, field shape, field orientation, complexity of the field is going to drive a lot of this. So when it's a disease issue, we may have to get into areas that aren't the easiest to fly into, kind of these low wet spots, maybe tree lined with a lot of Pennsylvania. Again, what's our target? What are we aiming to do? I think across the crops we work with quite a bit, it's a major issue.
So Paul, you mentioned here that you actually have an extra boom on some of these drones. Is that what I'm familiar with? Is you have the drone that's, and for our audience, we're talking about, this is like a 6-foot wide drone, right? It's not the one that you'd go real high up with and can image with. It's one that's really meant to. A lot of times we'll have nozzles like near each rotor, and they'll have 4 maybe rotors. Are there ones that actually get a farther width than that you're working with now, or?
Well, so you can use atomizers, which come out of the middle, that will give you a fine droplet. You can, depending on your rotor, you can have nozzles mounted on the rotor. So again, that combination is going to kick it out. You have to measure these in advance. There are drones that look more like a flat sort of boom that you or I would have on a tractor mount or a backpack sprayer. You have these different combinations. All of them are going to give you a slightly different spray width. And so again, the basic calculations we often apply to do that, or the height that we have to fly, some of the principles we apply for measuring it on a small plot or in a field setting don't quite adhere to that same principle. If you think about it in comparison to some of this spot spray technology that's really starting to come in for weed management, you have some advantages there. Your sensors are picking up what's kind of crop, non-crop as a starting point, and you can pinpoint it. We know the algorithms for some of our foliar diseases aren't quite there yet, because we have to differentiate a lot of different small lesion types, and that doesn't necessarily mean it correlates. So it's that combination of all of those factors that I think we still have to explore in greater depth and detail. But it's an area where, as the cost becomes more manageable for a farmer, many are jumping in to buy those. So how do we keep that research up with the speed with which the technology is changing? I know at Ag Progress Days, I think they're at a DJI of 50 liter, which is already larger than the ones we were testing last year. Carrying capacity, all all of this starts to influence how we think about the research, similar sort of questions, but as the technology just keeps changing a little bit at a time, how do we translate what we're seeing here and now?
So, Paul, we've got about 10 minutes left on this kind of research update. The question I would have, and maybe there's something else you want to bring to the front before we jump on this, but what does the farmer need to know about this, or what is their level of awareness they should have in 2024 as these things are being brought up and these things are getting kicked around of drones?
Ooh, that's a good question. So
Yeah, right. I was just thinking I need less open-ended questions, and then I kind of have
no, we spent a lot of the past winter in meetings with questions like this. So I was what's the right word? I was happy actually with a lot of the discussions, or pleasantly surprised also with some of the depth and detail we had. So I think the farmers are actually paying attention to this right now quite a bit. So I saw everything from questions about, do I go, how much should I be concerned with federal policies in the next year or two? So, and it's really driven by, are you doing federally contracted work? This could impact researchers, many of us potentially more so than probably some of the farmers. So you have that range of knowledge to, what are my rights? What are my rights as an owner of a land or a field or other terrain, if you will, especially here in Pennsylvania, where our farms are not all contiguous. It's not one field that links to the next field and so on. Those sort of questions. The farmers who seem to be at the forefront of adoption have some very simple thought processes. Simple is not the right word, meaning to minimize it, but simple in terms of, I see the economic value. I can pencil out the discounts I can get for a drone. So there are programs where you can get a pretty good refund, a tax refund or other on it. Plus the flexibility it gives me on my operation to go out and spray or put cover crop down, because again, it's not just one thing they're going to be looking at when I want to. Now then you start to draw a circle around the applicator cost piece to, how quickly can I get a drone out there if I need it? So what is my lag period between a report? And this could be, let's use tar spot as an example. If we hit the critical time and we're seeing an increase, what is the likelihood of loss if I miss that window by 7 to 10 days? Questions such as this. If I don't own the drone and I don't have access to ground equipment, which in a place like Pennsylvania is that occurs more often than not in some of the areas. All of these, I think a farmer has to take into consideration, because I can attest to this year, where we were getting some reports of tar spot and talking through with either the cooperative, a crop consultant, or others, talking about what they had access to, and the simple answer is often where we don't have access, or we haven't historically sprayed, so they're really not in a situation. And I think with drones coming online and more people coming on board with it, the pilots here in the area who work with farmers, there's been at least 2 or 3 that I'm aware of who just started operations this year, and they were already full up, if you will, for work. So farmers are looking for ways, but I'm also seeing some of maybe the more advanced farmers in this respect, they're not spraying the whole field. So those are other things. You can do actually kind of check strips in a little different manner. You can come in and say, if it's 200 acres, you can come in and hit a portion of that, kind of see how that holds up, and know if you have a little wider window, you can come back and still clean up the other thing. All of these things, I think, as a farmer's looking forward, they have to figure out, do they need it for the operation? It's still back to basic IPM. What are your issues and what would you be targeting? But then it becomes the same sort of question. how well will it fit in that operation. For some, it fits best when they're in control of it.
I think this is a great time to put the asterisk on this that says Paul's work and a lot of the information that Ryan and I have is kind of specific to Pennsylvania, right? And we know other people are listening to this from other states and maybe even countries. But if this is something you're interested in, right, like the FAA has involvement in this, your local state agency that governs pesticides and regulations and stuff. So, don't just get off of here and think like, boy, I'm going to get a drone and start spraying, right? This is a very complex kind of thing to unroll, and you need to be kind of doing your homework locally before you get involved in this.
Yeah, I would say from my other experiences, if I look in places in some areas like the tropics, I'm aware of some areas that produce banana on a large scale. Drones have started to replace, in many ways, airplane applications from you can truthfully you can buy a lot of drones for the cost of a single airplane, and you can run those with people who understand how drones work. You can do a lot more. So again, every situation is going to be a little different. But even on some of our large scale settings, as we go to the Great Plains or other areas, I mean, that's a mammoth exercise to be putting drones out there. And we didn't even touch on batteries and all of the other aspects of flying drones. They fit well into some of our environments because of the field size and shape where they are most appropriate. But again, not every field's going to benefit from taking that approach.
So it sounds like here, to summarize this a little bit, I kind of made a little list of some of the advantages and disadvantages. And so I just wanted to run through these and see if there's anything that I'm kind of missing. So when it comes to like why you might use a drone for a fungicide application, for example, some of the advantages are they help you to get to areas of the field you wouldn't be able to otherwise. If you don't have any access to equipment, but you have a disease problem, this might be a great way for you to get someone else to come out, and maybe it's more affordable than having all that spray equipment and a tractor and all those things. Although you probably have a tractor if you planted that field. It allows you probably access to spot sprays. That would probably be its best application right now. And so in its disadvantages, obviously limited access because there's not a lot of people who are doing this and they're booked out, and we're still doing a lot of research on how good the coverage actually is on these drones, and different setups might be different, and it may not be applicable to every disease system or ones that you need to spray a whole field. Is that, or a larger field, or is that kind of a good summary there?
Yeah, no, I think that's really good. That last one is really important. Talking with Brian Luck a little bit about it, we know there's a perimeter to area that probably fits well, which is a combination of the field size. It's a combination of the field complexity, because again, you can map all that in, but that doesn't mean every field's going to work really well, because even just trying to spray that with a ground rig is complicated and here again, focusing a lot more on Pennsylvania, our fields, they make for good science. They make for good backgrounds to do this sort of research, because we can't drive border to border, so to speak.
So if anybody out there is a drone operator that's running their commercial business listening to this podcast, and you have interest in coming on and answering all of our questions on how all this works, please reach out to Ryan Spelman. We'd be happy to have you join us. But like Paul said, one of the big questions I have, and most of you, if you listen, know I'm in Western Pennsylvania, kind of becomes this like setting up and moving thing, right? Like you've got to maintain line of sight. And Paul's kind of brought this up about our fields. If you're spot spraying 1 5-acre field and you've got to maintain line of sight, like I feel that your day would just be this perpetual unpacking and repacking constantly to get from this field to the next field to the next field. And we talk about applications in pasture, especially, right? Like traveling some of this traverse terrain behind and in and out of hollows and stuff. They're questions, right? They're not whether it makes sense or doesn't. It's just, what's the question mark to this, and how feasible and time consuming is something like that for these people?
definitely. I'd agree with that. And that's what we're required to do when we work with drone pilots, whether we're working on Penn State University research ground or with our private farms. In the same way, we have all these rules and regulations, and that line of sight one is probably the biggest one that comes up.
Awesome. Well, I guess we're wrapping up on time here, but if I can have you maybe answer this one last question, and then we'll let you get out of here. Where do you see this drone spraying tech going in the future? And maybe what are you most excited about in your research on this technology?
Yeah, well, we just received, and I think that's a recognition of the needs and the questions we have to deal with. So we just received some funding from the Northeast SARE, the Sustainable Agriculture Research and Education Program for the Northeastern U.S., a partnership grant to continue to do on-farm research for white mold. We see this as an area for us to explore across the different field layouts we have. That is valuable. The preliminary data is promising. But as we continue to refine, I think we'll be spending the next couple of years on that while we do some other work. But that's probably going to be our main focus as a smart target for what we need to be focused on.
Awesome. Very cool. Well, thank you for joining us. We really appreciate having you on and trying out this new format.
All right. Thank you both. It was great to be here.
All right. Well, I think that was a interesting conversation with Paul. You know, I think there's so much to still learn about drone technology, and it seems like the research is really just trying to keep pace with what's going on and what's already being implemented out there.
But it is exciting, right? That people are interested in new stuff. It always excites me when some of our older farmers are still actively looking for new technology and new options. So, I mean, at least we're continuing to keep up, and we're doing our best from a university level to keep giving them the information they need and the training that they want to be able to advance technologically.
Right. Yeah. And I think that's where a lot of research is nowadays in this space is there are so many options out there today, and it's about how do we provide the best education and add the science into that to say this is how you use this technology and this is how it's most effective, right? So that's not to say that research is behind at all. It's just to say this is our role in this space. So I think that's probably a great bridge now to bring in something, again, a new technology that is kind of in addition to some technology we've had for a very long time. And that's some of our more precision agriculture spray technology, specifically in the herbicide space. So we have one of our specialists here, Dr. John Wallace. He's our weed specialist with Penn State Extension, to talk a little bit about seed spray technology. So, John, why don't you introduce yourself here and maybe you can introduce a little bit on some of the research you're doing in this space.
Sure. Thanks, Ryan and Justin. Yeah, so I'm an extension weed specialist here based on campus, and I focus on weed management in field and forage crops. And really my research program, I would say, is really focused on some of the tried and true kind of weed management approaches. So thinking about kind of diversifying your weed management toolbox using good crop rotation, diversity, and cover crops and other types of cultural management practices. And so certainly, new technologies and site-specific weed control technologies can help supplement those kind of other weed management approaches. And so we've been looking for opportunities in my program to start to work with new and emerging technologies that might have a fit here in Pennsylvania field crop production systems.
Cool. Yeah. So you mentioned this new and emerging technologies. So what do you see in this space for some of this, specifically the See and Spray technology? What is the current status of that technology? There's a lot of excitement that I hear about this, that we can apply less herbicide and more target specific weeds, right? There's this whole idea of how can we reduce our spray applications but still target weeds, and that to me seems like where a lot of the innovation in this space is kind of heading, is answering that question. But, how does this work and where are we currently with this technology?
Yeah, so there's really been really significant, I would say, technological advancements that have led to this idea of using kind of real-time camera-based weed detection systems outfitted on commercial sprayers that allow us to do site-specific herbicide applications. And so, you hear that referred to as spot spraying or patch spraying. And the real kind of potential benefit for this technology, really, there's two benefits. One is to the producer, that's going to allow us to reduce herbicide inputs and therefore input costs, and really has the potential to generate significant reductions in input costs. But with that, there's also going to be an environmental benefit, right? As far as just spraying fewer pesticides in our production systems. And this is also kind of becoming increasingly important as we hear about EPA's renewed efforts to reduce pesticide exposure to endangered and threatened species, and the new mitigation efforts for reducing off-target movement through drift and surface runoff. So there's both kind of an economic benefit to the producer, but also these potential environmental benefits. And so where we're at with the technology, we've gotten to the point where now there's kind of commercially available systems to do this. And so we're going to talk a little bit about my experience with the John Deere See and Spray technology, but that's really just one commercial product. There's a few others out there. So there's One Smart Spray, which is a similar kind of technology platform that's a collaboration between Bosch and BASF. There's Green Eye Technology, which is a similar platform. So there's kind of multiple kind of different types of platforms that are coming to the market right now. And so I would say broadly what all those technologies allow producers to do or applicators to do is to either what we would call make green on brown applications. So that would be to spot spray emerged weeds in the field, perhaps in a no-till production system where you're in a fallow stage. And so you're just going to come in and spray those emerged weeds prior to planting. But there's also the ability with these systems to do green on green spraying, which means to selectively make applications to weeds that have emerged and are within a crop stand. And so right now we can use that technology in the green on green applications for either corn, soybean, and in the South, cotton production systems.
So this is a very loaded question, and I apologize, but one of the things that you mentioned was this environmental compliance and the things that can change and stuff. And one of the big questions I have with technology is how do we close this gap between the person on one end of the spectrum with the See and Spray and this other person on the far end of the spectrum that has, and nothing wrong with this, but I'm using this as an example, this homemade sprayer that they're using, that regulating, even knowing sometimes our pressures don't make sense, or the people that aren't calibrating, right? We have this huge spectrum left to right. How do we get all of these people caught up and on the same page to get them closer to compliance when something like this changes? Is that driving research? Is that driving dollars? Where do we go with that?
Well, that is a loaded question. A good one. I would say that certainly when we think about compliance when it comes to kind of mitigating off-target movement through drift or surface runoff, we start with the herbicide label, and we're going to see some new restrictions in labels probably related to this. And so there's a educational component that you and myself are involved in, correct? And so I think that's one part. But you raise a good point that beyond the education, that technology is going to really impact our ability to do the best job of kind of mitigating those risks. And that's from my perspective, just kind of seeing this new technology, there's certainly an issue related to scale because of how much technology is involved in kind of the capital investment that's needed to gain access to that technology. And so that's gonna mostly, you're gonna find yourself where larger producers or maybe commercial spray outfits or co-ops might be the first to adopt that type of technology, and that perhaps leaves behind, the many small to medium-sized farms here in Pennsylvania that are working with older spray technology. And so certainly, there's different levels of engagement, right? There's probably a few things that could be outfitted on even an older spray system using aftermarket kind of products, right? And so you're not buying the whole system, you're making some upgrades to an existing system. So there's certainly opportunities for that, and that would be a good first, a good place to start.
I think you're right. Like there's this big gap in these newer technologies. They might not be relevant for most of our producers, right? But it's maybe an eye into the future of what might come down the line eventually, and it can, change the conversation, right? And maybe it's a technology that might eventually become more commonplace, but it's just, in the future. So in talking about this is a really kind of, it is a commercial technology now, but not a lot of people are using it right yet. And to that point, you mentioned this, like the green on green and green on brown. And so when you say that, that makes me think that the green on brown, it's probably, when we're talking about herbicides, this is limited to, maybe you did your burn down, and this is a pre-emergent managing weeds before your crop emerges, and then you have your green on green, and that might be post-emergent applications, right? So how much in your research so far do these technologies, are they doing what they say they should have, saving you on how much herbicide you're putting on your field? Probably depends on how weedy your fields are. Like, I guess, how effective are they in this newer phase in that technology?
Right. So this summer has been my first opportunity to see this in a commercial setting, and so thanks to funding by the Pennsylvania Soybean Board, as well as kind of cooperation from John Deere and LandPro, we were able to basically follow on-farm kind of demonstration trials that was done across over 400 acres on a kind of a large Western Pennsylvania farm that's already using John Deere's latest technology when it comes to this type of sprayer. And so we were unable to, this first year, be able to evaluate green on brown spraying. And so just to back up as far as where I think the fit is there, Ryan, so certainly we have a lot of no-till acres in Pennsylvania. And so you can perhaps understand the potential benefit for kind of cost savings when you think about what some of those no-till fields might look like in early April, let's say, where you might think about coming in and making a burn down application maybe a few weeks prior to planting. Depending on what your weed pressure is and kind of the winter annual weeds or maybe some perennials that you deal with, those fields might be fairly patchy. And so that's a real opportunity to reduce your total volume of herbicides out there using this patch spraying or spot spraying technology. And there was really some great research that was done probably 30 years ago in the 1990s about the potential for spot spraying technology in no-till production systems. And that work was kind of done prior to the technology being ready. But we learned a lot about kind of what the most important things are from a weed ecology standpoint. And so your potential to see cost savings is not just a function of how many weeds you have in the field, and so weed density or just kind of how much weed pressure you have, but also how aggregated or patchy those weeds are in the field. So if you think about a small field with 1,000 weeds, if they're kind of equally distributed throughout the field, your cost savings is probably going to be less than if those 1,000 weeds out in the field were just in a few 2 or 3 patches within the field, right? And that's because there's always going to be some overspray each time you're targeting a single individual plant. And so the more that those plants are aggregated, you know, there's going to be just more cost savings. And so one of the questions I was interested in answering from a green on brown application scenario is, on your average no-till production field in Pennsylvania, what do those kind of winter annual weed distributions look like, and how is that going to kind of determine the potential for cost savings? And so I think that's something that we're going to continue to try to look at. But we were able to do this summer was to look at the green on green spraying. And so the context for that would be, in a no-till system, you've applied a pre-plant burn down application. You know, typically we would like to see a two-pass herbicide kind of program approach in those no-till production systems, where you would use a pre-plant soil residual kind of herbicide program to start clean. And in that second pass, post-emergence pass in crop, you'd be coming in with a you know, a foliar program to control those weed escapes. And that's the opportunity for the green on green patch spraying to really reduce your inputs. And so I think what we learned in evaluating that this summer was a couple things. One, certainly those weed distribution patterns are important for determining what your cost savings are, but there's also kind of probably a learning curve to decide how you should adjust your herbicide program up front when you're using this type of technology, because the stronger kind of pre-plant herbicide program you use, the stronger it is. You'll have fewer weed escapes in that post-emergence pass, and therefore you'll have even greater potential savings from the spot spraying, right? So that's really deciding on that balance between kind of how strong of a residual herbicide program you might use when you're using this spot spraying technology. It's probably going to be a little bit different depending on what type of production system you're in. And so we actually did not see a tremendous amount of cost savings on the farm that we were at, as far as kind of the input reduction relative to just a broadcast application. And that was because the system that we were working in, we were on a farm where there was a lot of small fields. And because of that, there was a lot of edge habitat, right, relative to kind of the interior of the fields. There in Western Pennsylvania where we were, there's also, you know, deer pressure on the edges of those fields. And so the edges of those fields tended to be fairly weedy, with wheat kind of a lot of weed escapes. And so when that spot spraying application was being made, it was essentially on the entire time, similar to just broadcasting, because of the amount of weed escapes that we were dealing with on those field edges. And we saw kind of weed density decline and fewer areas where there was no weeds in the interior of those fields. So kind of the field size really determined how much potential cost savings there was. But on that farm, we were also dealing with a lot of kind of what I would describe as no-till weeds that aren't necessarily weeds that are going to rob yield or be important from an economics standpoint. So dandelions, small weeds like yellow wood sorrel, and they were distributed enough throughout those no-till production fields that the spot spraying, you know, the sprayer was essentially turned on a good bit of the time. And so we learned some, you know, I think we learned a few things this year, and we'll continue to learn if we get the opportunity to see this technology on other types of production systems within Pennsylvania.
So it sounds like a lot of the research you're doing here is also to understand what are some of in what applications might there be adjustments that need to be made to the tech as well. So it sounds like it currently where we're at now, is there a way to differentiate like weed size, right? You're saying there's a lot of those smaller no-till weeds that can you differentiate between a dandelion and, you know, something that might become a bigger problem like pokeweed or something? Like, I guess that's one question. Are they working on that technology? Is that available yet?
That type of technology is not available currently, but that type of research is ongoing. And so right now, as far as the technology that's commercially available and for John Deere See and Spray systems specifically, the way that in which weed detection is occurring, and it's proprietary, so we don't know the exact algorithms, but essentially in a green on green scenario, it first recognizes what is or is not a corn or soybean plant. And some of that is pattern based. So picking up the patterns based on whether you're on 30-inch rows or 15-inch rows, but also recognizing kind of pattern recognition of what those crops look like, right? And so once it knows the crop, then any detection of kind of green matter it finds out there is therefore a weed, right? And it's not distinguishing the size of the weed. It's not distinguishing which weed species it is. It's just distinguishing that it's not a crop, and that's going to trigger the nozzle to go on. There, in this system with the John Deere See and Spray, as well as I believe these other systems, there is a little bit of some fine-tune adjustments that an applicator can make in order to accept either more false positives, in order to be really, if you want to be risk averse and make sure that you're catching anything, or to accept more false negatives where maybe you want to allow a few of those really small plants to go and not spray those individuals. And so that's also that right now, that's really the only way to kind of maybe turn that sprayer on and off based on the size of the weeds. And so certainly there needs to be more work done to kind of understand the cost benefit and kind of the risks involved with how you accept those false positives or false negatives. But certainly we're heading towards the direction of being able to differentiate weed species in real time. And so that is the next generation. And so understanding which weed species you deal with in real time may allow you to target specific driver weeds. So let's say you have a horseweed problem in Western Pennsylvania, and really what you're trying to do in that post-emergence pass is to get those horseweed escapes or other weeds that we think about having maybe zero tolerance for, that we want to really prevent from going to seed. So if we were able to detect different weed species, we might be able to someday down the road decide which weed species we're going to target that post-emergence pass, while allowing those maybe less economically important or less competitive weeds go and generate some more kind of input savings.
Awesome. It looks like we're coming close to our time here. So I guess I'll leave you with one last question for you to answer here. And my question is, in this space, is there a research question that you might be really excited to ask? Something that excites you about this space in the future, or where you see this going? I think you kind of answered some of the where you see this going.
Yeah, well, I mean, I think it's really kind of fun from a research standpoint, and exciting to understand how this type of technology fits in our production systems in Pennsylvania, right? And so there's some unique things about Pennsylvania when it comes to, our crop rotation diversity, but also kind of our demographics. We farm small fields, we farm a lot of varying topography, and so we have kind of unique weed management problems in Pennsylvania. And so understanding the benefit of this spot spraying or kind of site-specific weed control is going to be important. But I started out talking about kind of the focus of my program being integrated weed management. And so to me, the real exciting part is what do our weed management systems look like when we can integrate this type of precision technology, spot spraying, site-specific weed control, in combination with other good weed management practices, right? So stacking tactics. So using cover crops, using post-harvest weed seed control, in addition to these types of site-specific weed control strategies. You start stacking those types of tactics down the road, and I think you're looking at a pretty sustainable form of weed management where we might see less evolution of herbicide-resistant weeds. We might be able to preserve those effective herbicides over the long term. And so I think that's kind of the promise of this technology, is when we put it in the toolbox with the other kind of weed control practices.
Yeah, that's great. This concept of a toolbox, it's something we always talk about in IPM or IWM, right? Weed management. And the goal is always to either expand that toolbox or preserve the tools in it, right? And this technology, maybe it can do both, right?
And I
Yep.
think that there was a very common thread. John, I know you weren't with us when we talked to Paul, but it comes up with him and the drones and the fungicides, as well as with what you were just talking about, our field size, our topography, undulation, everything changing. And that's what kind of gives us the opportunity for these things to work maybe better in this region, or us having a nice canvas to test these types of application compared to maybe some others. And so it really does give us a nice position here in Pennsylvania and with the university and with extension to continue working and researching and hopefully answering more of these questions that producers may have and giving them more opportunities to see this stuff into the future.
I totally agree. We're just scratching the surface, and I think, you know, the beauty of it is like my project was a collaboration between industry, Penn State Extension. We did on-farm, you know, evaluations of this, working with producers that are interested in this technology, and we were funded by the Pennsylvania Soybean Board. So there's really a lot of people that were invested in this, and I think that's going to need to be kind of the standard to really understand what this technology can do.
Well, thanks, John. I appreciate you being here with us. And Ryan, I don't know, we've gone about an hour now. I think maybe this would be a good place to break for this episode. And anybody that's listening, we're going to do another episode or two on this ag technologies coming up in the coming weeks. So stick around. We think this is a nice kind of break from what we've been doing, but getting to really showcase our specialists and what they're doing at the university level, and getting this information brought to you. So again, thank you, John, Dr. Wallace, for being with us. And Ryan, as always, it's been a great day, and hopefully someone really enjoys doing this. So until the next one, take care.